Week number 2, we're looking at the subject of the fine-tuning of the universe. The fine-tuning of the universe. What is fine-tuning? Here's a good working definition. The laws, constants, and initial conditions of the universe could have been different, but are exquisitely finely tuned for the possibility of life to exist. So ever since about 1974, physicist Brandon Carter discovered one of the many examples of fine-tuning in the universe. And this has really blossomed into an argument for the existence of God over the past 50 years or so. Let's look at this definition more closely. For one, when we refer to the laws of physics, we're at least referring to the 4 fundamental forces of physics. Gravity, which is by far the weakest force, the electromagnetic force, which allows heat distribution, and chemistry, the periodic table, the strong and the weak nuclear force, which allows for atoms to bond and to exist, as well as more types of laws. The Pauli exclusion principle, you can have no more than 2 electrons on a circuit in an atom, and many more, okay? But at least these here, the 4 fundamental forces of physics. When we refer to the constants of physics, what we're referring to there are the numbers that are plugged into the laws of physics. So, for example, the gravitational constant, which could be represented here. The force of gravity is the gravitational constant G multiplied by m1 multiplied by m2 divided by the inverse squared of the radius. And finally, the initial conditions of the universe. This could be explained as the initial distribution of mass energy, or what Roger Penrose referred to as the incredibly low entropy of the universe. So, the laws, constants, and initial conditions, basically these certain aspects of physics that really govern physics, these could have been different. People say, well, the force of gravity, it just is that way. Yes, it is that way, but it could have been different. It could have been, on a scale of 10 to the 40th power, different in its strength. Instead, it's incredibly weak. Well, what about the strong nuclear force, the strongest of the 4 fundamental forces of physics? That, again, even though it's very, very minuscule, it's very strong, and it could have been different. The weak force, the electromagnetic force, these could have been on a different scale. So people just saying, well, that's just the figure. That's a really naive view of these fundamental forces and really these initial conditions. Here's Leonard Susskind out of the University of Stanford. He's a theoretical physicist. This is from his book, The Cosmic Landscape. He writes this: an infinite number of other lists or constants are equally possible. The properties of gravity, especially its strength, could easily have been different. In fact, it is an unexplained miracle that gravity is as weak as it is. So he's explaining the very notion that these certain constants and initial conditions could have been different than they are. So physical necessity, that they have to be that way, does not even remotely explain the fine-tuning of the universe. These are exquisitely, astronomically finely tuned. It's hard to use adverbs to describe this. It's unbelievable how finely tuned these constants, laws, and initial conditions are for the possibility of life to exist. There's the key word, possibility of life. Not that evolution could have gone a certain way and we would have looked more like Klingons or Vulcans, or we would have been a different form of hominins or rats or reptilian species. No life, no possibility of life in the universe. Certainly not conscious life such as ours. Who affirms this? Who affirms what I just said? Everybody. Everybody. The only one I could find is the late Victor Stenger out of the University of Hawaii, and he has a book called The Fallacy of Fine-Tuning. He is the one outlier that I could read and discover. Everyone else turned on Victor Stenger, even his secular friends, because he's so completely out of tune with what's going on in this area of physics that everyone agrees with what I just said. Physical necessity doesn't explain it. Chance doesn't explain it. These properties could have been different, and yet here we are with this mystery of the universe, that if these constants, laws, and initial conditions weren't exquisitely fine-tuned, there would be no possibility of life. I can't stress that enough. So, physicists such as John Barrow, Frank Tipler, Bernard Carr, Brandon Carter, Paul Davies, Brian Greene, Alan Guth, I could go on and on. I mean, everywhere from Oxford University to Stanford University and everywhere in between, this is something on which everyone agrees. Brought this video along here to show you this. Check this out.
All right, let's talk about one of them, though, that has some particular strangeness to it, the so-called cosmological concept.
That's right. That's the one which is really on a knife edge. Okay? It is on such a narrow knife edge that it's almost inconceivable. This constant, whatever made the universe, I hate to say whoever you made the universe. Physicists have a habit of talking in that language, whoever made the universe. They don't really mean it. But whoever made the universe made it with an incredibly small, tiny cosmological constant. It is so small that it is 0.00000. We can sit here for a while. Yeah. 123 of them.
And then a 1.
And then a 1. I think it's actually a 2. Yeah. But it is incredibly small, and nobody really knows why. So if it were just a little bit bigger than this 0.00000, it would have prevented our existence. Physicists have never understood why it's so small. On the other hand, this cosmological constant is tuned to 1 part in 10 to the 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident.
So, in all of these cases, with the electron mass, with the proton mass, with the cosmological constant, which is vacuum energy, the only explanation that we have right now of these coupling constants is that if they would be much different, then our life would be impossible.
And there's also the gravitational fine structure constant, which is tiny. It's 10 to the minus 40. And so the reason it's so tiny compared to the electric fine structure constant means that the gravitational force between 2 protons, for example, is 10 to the minus 38 times smaller than the electric force. Now, a lot of the coincidences, the anthropic tunings, involve these dimensionless coupling constants. It seems we need both types of stars in our universe, but the only reason they exist is because of this remarkable fine-tuning which says the gravitational fine structure constant is the 20th power of the electric fine structure constant.
It's certainly the case, and I think this is now uncontroversial, that if the laws of physics were very slightly different in almost any way, there could be no life in the universe, no complex chemistry, and no thinking people, and therefore no one who knows the laws of nature. So they are somehow almost infinitely special in that they allow themselves to be, as you said, not just known but also used, and that they were used before humans even existed to create life, and then for the human species to evolve.
But what we seem to find in the universe that we know is this and this. That is, it was very uniform, and with regard to the matter, okay, it was maximum entropy, but with regard to gravitation, it was very, very special. How special was it? You can actually work this out. It's so special that the odds against the special initial state coming about by chance are less than 1 part in 10 to the power 123. So, if you try to write this out 1000000, with this number of zeros, you'd try to put 1 0 on every particle in the observable universe, you'd be way short. You'd never do it that way. That's not enough room to put all the zeros in, so I can do it by using 2 exponents, you see, but that's cheating, if you like. I just want to give you some feeling for how special the initial state of the universe was. And for some reason, people, they try and say, well, you don't want such and such a theory or so-and-so theory because that requires fine-tuning or something like that. Well, there's got to be fine-tuning. This is fine-tuning. This is incredible precision in the organization of the initial universe.
None of those people in that video are Christians. None of them are believers in God. These are secular scientists, as you could see, Stanford, Oxford, Cambridge, and yet they're all agreeing on the same fundamental principle that the universe is exquisitely finely tuned for life. To this list, we can add not a physicist, but a biologist, Richard Dawkins. This is from his book, The God Delusion, so he's not going to go easy on us here. He says, physicists have calculated that if the laws and constants of physics had been even slightly different, the universe would have developed in such a way that life would have been, and there's the word again, impossible. Now, Richard Dawkins is more Darwinistic than Charles Darwin, and he believes that we could get some kind of an ability with, natural selection acting on random mutation. And here he's saying, no, this precedes the neo-Darwinian synthesis. We wouldn't have the particles, we wouldn't have the elements, we wouldn't have the ability to even get life going without this. The only other person I could see who disagrees with this is Dr. Ian Malcolm of the University of Texas at Austin. This is what he says.
It's not possible. Listen, if there's one thing the history of evolution has taught us, it's that life will not be contained. Life breaks free, it expands to new territories, and it crashes through barriers painfully, maybe even dangerously, but life finds a way.
I love that clip. I love Jeff Goldblum. I love that movie. I love Michael Crichton. I love everything about that. In this case, it's just dead wrong, though. This is nobody believes that life could have evolved without this prerequisite, this precursor of fine-tuning. Some people, just to dig down deeper, will say, well, what about silicon-based life? You're only thinking in a narrow concept of carbon-based life. But what if we broaden it out to silicon-based life? Great idea. Silicon-based life is another way that we could form life. Well, let's see how silicon compares to carbon with regard to hydrogen. Now, hydrogen is by far the most abundant element in the universe. And so we can do the math on this. We can look at all of the different elements on the periodic table, and we can see the different amount of chemical compounds that can be made with hydrogen. So lithium and hydrogen, 4 chemical compounds. Beryllium and hydrogen, 6 chemical compounds. Nitrogen, 65. Silicon, 55 chemical compounds with hydrogen. And silicon is closest on the periodic table to carbon. So this would be our best bet. Let's compare silicon-based life with carbon-based life. How many chemical compounds can carbon make with hydrogen? 29,000. So when people say, well, what about silicon-based life? I hope you realize that's not answering the fine-tuning problem. That's only adding to the problem. Carbon is far, far, far more likely to produce life than silicon-based life. And what we're going to discover here is that the fine-tuning problem doesn't just require us to look at silicon-based life or carbon-based life. This is going to wipe out the periodic table completely, or nearly completely. What are examples of fine-tuning? Here is one of them, the Q constant. This is the uniform temperature of cosmic microwave background radiation. It's evenly distributed to 1 part in 10 to the 5th power. So a 1 out of a 100,000 chance. If this was decreased, we would have no stars, no planets. If it was increased and this uniform temperature wasn't quite as uniform as it could be on the part of 1 out of 100,000, the stars are too close together and we would have no stable planets. So this is a damned if you do, damned if you don't. You move either way on the dial of the fine-tuning and we don't have life. Well, maybe it could have evolved. No planets. Well, maybe it could have evolved. No stars. None of the elements that are needed that come from stars, that life evolves on planets. Years ago, Fred Hoyle, the atheist astronomer and scientist, he made a science fiction book in which he had conscious gas clouds. And that works really well if you're an Isaac Asimov or a Fred Hoyle in science fiction. This doesn't work in the real world. We wouldn't have planets or even the heavier particles that we need, elements in the universe. What about the weak nuclear force? This is finely tuned to 1 part in 10 to the 9th power, or 1 part out of a billion. 1 in a billion chance. Without the weak force, one of the 4 fundamental forces of nature, physics, without this being finely tuned to 1 part in a billion, we would have no supernovae, that's the plural of supernova, and hence we would have no life-essential elements. When stars supernova, they seed the universe with the necessary elements to create life. What about the omega constant? This is the mass density of the universe. This is finely tuned to 1 part in 10 to the 24th power. That's a 1 with 24 zeros after it. Now, so far I've been saying 100,000, a billion. At this point, there is no number of which I'm aware that we could, a quadrillion, trillion, billion, I don't know. At that point, I kind of sound like a 6-year-old, right? 10 to the 24th power, if this mass density of the universe wasn't precisely finely tuned, the universe would have collapsed because the mass density would have been too strong that when the Big Bang blew, it would have brought it back together. Within the first 7 billion years, the universe was slowing down and then dark energy kicked in and now it's accelerating. Or on the other hand, it could have been too low and the mass density wouldn't have been able to slow down the universe, and so there would be no galaxies or star formation. So if the mass density wasn't just right, not too high, not too low, not too hot, not too cold, not too soft, not too hard, in the Goldilocks effect, just right, we wouldn't have a universe, and we wouldn't have galaxies or stars. What about the ratio of electrons to protons? This is finely tuned to 1 part in 10 to the 36th power, a 1 with 36 zeros after it. If this wasn't finely tuned in our universe, there'd be no galaxies, no stars, no planets, just extremely diffuse gas. What about the N constant? Electromagnetism to gravity, finely tuned to 1 part in 10 to the 37th power. If it was increased, no small stars. If it was decreased, no large stars. So we would have either a universe in which we only had red dwarfs, or which would be unstable for planets, or we would have a universe with no slow, stable, burning stars that would allow for life to exist. What about gravity compared to the weak force? This is finely tuned to 1 part in 10 to the 50th power, a 1 with 50 zeros after it. If larger, no galaxies. If smaller, the universe would have collapsed. Now, I'm not quoting or citing any Christians solely in these annotations. The 2 Christians I am citing are Luke Barnes and Robin Collins. But whenever I cite Robin Collins, who's a Christian professor at Messiah College, I will always give you an atheist or an agnostic. And when I cite Luke Barnes, this is from his recent book, A Fortunate Universe, which he co-authored with his atheist colleague, Geraint Lewis. So they both spend the first, 7 chapters saying, we agree on the science. What we disagree on is the interpretation of the science. Not the physics, we agree on the physics. What we disagree with is the metaphysics. How do you explain the physics? So I'm kind of jumping into the ring here with 2 arms tied behind my back, but I'm trying to show you this is what naturalistic science teaches. This isn't creation science. This isn't anything of the sort. This is just the data that we see. Let's look at just one of these constants a little bit closer, the gravitational constant. This is represented by that equation I mentioned earlier. F is the force of gravity, the force of gravity. It's equal to G, the gravitational constant, multiplied by M1, that would be the mass of one object, multiplied by M2, the mass of a second object, divided by the radius squared. That's how you get the force of gravity. So M1 could be the Earth, M2 could be the moon. Or M1 could be the sun, M2 could be Jupiter. And that could change. The radius between those 2 masses could change. So if it's M1 is the Earth and M2 is the moon, that's a radius of 239,000 miles. Squared would be the inverse proportion. So M1 could change, M2 could change, the radius squared could change, but G, the gravitational constant, is always the same. And this is finely tuned to 1 part in at least 10 to the 35th power. So, how do we get that figure? I'm going to try and drill down a little bit. Stick with me here. How do we get these numbers? This is compared to the strong nuclear force. So the strong nuclear force is the strongest force among the 4 fundamental forces of physics. Then gravity is the weakest force. Well, the strong nuclear force is 10 to the 40th times stronger than gravity. Or to put that a different way, gravity is 10 to the 40th times weaker than the strong force inside of an atom. So that puts us on a spectrum of 10 to the 40th as all of our different possibilities. Now, within that spectrum, there is a life-permitting range of 100,000 window that if you moved just a 1 or a 2 a 3, a 4, a 5, a 10, a 15, 200, 10,000, 99,999, 100,000, within that range, you could alter gravity. It would have deleterious effects on life, to be sure, but it wouldn't kill life. There's at least a range in there that if you moved it a little bit within 100,000 on that spectrum of 0 to 10 to the 40th power, 10 to the 5th is somewhere in between. What this means is, a conservative estimate is that we're betting with 100,000 in a roulette wheel of 10 to the 40th power. Or, if we want to make this simple, you get rid of 10 to the 5th, and you go down to 10 to the 35th. One part in 10 to the 35th power. Buying 100,000 lottery tickets when there's 10 to the 40th possibilities is a drop in the bucket. It doesn't even come close. I know many of us didn't grow up with math, and you're not really sharp on math, and you're like, well, 10 to the 5th, that's, what is that compared to 10 to the 40th? That's like an eighth of the size. No, these are exponents. 10 to the 6th is 10 times 10 to the 5th. 10 to the 7th is 100 times. 10 to the 8th, you get the idea. 10 to the 40th is 10 to the 35th times the figure that we're seeing here, which is that narrow fraction. So you could say it's 10 to the 5th out of 10 to the 40th, or let's just make it easy. A conservative estimate, 10 to the 35th power. If gravity, this gravitational constant, was weaker, stars wouldn't get hot enough to create carbon. They would never supernova. There would be no supernovae in the universe, which would mean they wouldn't have that nuclear fission where the gravity is pulling in on itself, and eventually it's going to explode out into seeding the universe with these life-enhancing and permitting elements. However, if we move on the other direction, if it was stronger by 1 part in 10 to the 35th power, only short-lived stars would exist, and the heavier elements would be no heavier than carbon and oxygen. So either way, you're dead. There's a bunch of ways to be dead, very few ways to be alive, on the order of 10 to the 35th power. Now, that's a hard number to even comprehend, and I know I was throwing a lot of numbers at you here. So let's use some illustrations to look at this number. That's the figure there, 10 to the 35th power, a 1 with 35 zeros after it. Let's say tonight you're thinking about retiring early and having your grandkids retire early, and you're feeling lucky, and the stars are aligned, and you're going to play the Powerball. What would the odds of winning the Powerball be? 1 out of 300 million. 1 out of 300 million. But that's not even getting close to our figure, obviously, right? So let's kick it up a notch. What about the number of cells in the human body? Let's say some kind of a surgeon said that we need to remove 1 cell at random from your body in order to cure you of whatever deadly disease that you have. What would the odds of that being the case, actually coming through to the point where you actually survive the surgery? 1 out of 37.2 trillion. So who would sign up for that surgery? That would be basically a sign. That's 1 out of 37 trillion. We're not doing the surgery. It's game over. What about the number of seconds that the universe has existed? The universe has existed for 13.7 billion years, but if we were to quantify that into seconds, that would be 10 to the 18th power since the universe began to exist. So we're still not getting close. And again, that isn't half of our number. We're not halfway there. 10 to the 19th would be 10 times that figure. We need to get up to 10 to the 35th power. Let's kick it up a notch even further. Let's say we had a God's eye view of the entire material universe, and we had a God-sized Stanley tape measure, and we stretched it all the way across the material universe from one end to the other, and we split up the universe, 15 billion light years across, 20 billion light years across. We split it up into inches. What we're saying here is that if the gravitational constant was 1 inch weaker, no life. By contrast, if it was 1 inch stronger, no life. It needed to be precisely on the right inch, precisely in the Goldilocks effect, just right. The problem with this illustration is that this is only 10 to the 28th inches. This falls way short of the gravitational constant, which is 10 to the 35th power. So, can chance Explain fine-tuning. I've talked to some people and they say, well, there was a chance, and so if there's at least a chance, that means it's possible. Reminds me of this movie here.
I'd say more like 1 out of a million.
So you're telling me there's a chance?
Yeah! Yeah, I love that film. I love Jim Carrey, too. That was his best film. Anyways, the point is, when we watch that movie, what is the redhead telling Jim Carrey? There's no chance. All right? 1 out of a million. For us to sit here and say, well, there was a chance, 10 to the 35th power. And this isn't the worst of it here. Check this out. Other examples would be the lambda constant, the cosmological constant. This is one of the firmest constants in physics, which was alluded to in that video. This is finely tuned to 1 part in 10 raised to the 120th power. A 1 with 120 zeros after it. So 0.0000000. I could be here for 2 minutes saying a 0 every second and still come to the end of it and then say, and then a 1 at the end. That's how low the cosmological constant needed to be. If it was any larger than this, any larger than that level of its constancy, the universe would have consisted of a hydrogen and helium soup. There would be no life. It gets worse. I just keep giving you the bad news. It gets worse than this. The low entropy of the universe, we studied entropy already, didn't we? Disorder, that energy becomes unusable. The low entropy of the universe that has a low disorder is figured by Roger Penrose to be 10 to the 10 to the 123rd power. As Penrose stated, to write that number with a 0 on every subatomic particle in the universe, that would only be 10 to the 80th subatomic particles, you still wouldn't be able to write that number. Barnes and Lewis, in their book, A Fortunate Universe, go further, if that wasn't good enough. They said you would need 10 to the 43rd universes with a 0 written on every subatomic particle just to write that number. 10 to the 10 to the 123rd. As Penrose himself said, I can cheat and use a double exponent, but that number is, I don't want to say near infinity because that's a contradiction, but that number is so far out, we have no way of even comprehending how finely tuned that even is. Well, how many examples of fine-tuning are there? Roughly 30 laws, constants, and initial conditions. If you want to be very conservative, the most conservative scholar that I've read on this is actually a Christian. Robin Collins out of Messiah College or University says that he only uses 6. In his published work, he only uses 6. I kind of like that approach. 1 is enough. 2 is just beating the person up. 6 is just bludgeoning the person. Paul Davies, however, and Max Tegmark, a number of other, I'm talking top-tier academicians, they say there's somewhere between 30 and 31 of these fine-tuned constants in our universe. Well, how can we clearly communicate this argument to other people? Remember I said at the beginning of the course, we're going to start really complex, we're going to get into the science. How do we communicate this in a concise manner? I would suggest for homework, which is optional, but if you love God, you'll do it. I would suggest that you memorize just 1 or 2 of these examples of fine-tuning. If I was you, I would suggest memorizing the gravitational constant, because everyone knows about gravity. You wouldn't be intimidating a person if you were sharing this with them, talking about the uniform background radiation of the universe. To say the gravity needed to be a certain strength or a certain pull against the strong nuclear force, that's common ground. And to say that needs to be finely tuned to 10 to the 35th power. Or the cosmological constant needs to be finely tuned to 10 raised to the 120th power. You could do that, which would be that the universe has an expansion rate. See, initially they said the expansion rate of the universe needed to be finely tuned to 10 to the 60th power. And they said, well, that can be explained by the cosmological constant. So we've explained that fine-tuning away. Really? So what do you explain it away with? The cosmological constant. Well, what's the fine-tuning of the cosmological constant? 10 to the 120th power. So we explained one of the aspects of fine-tuning by only increasing it in another realm. So memorize 1 or 2 of these examples Think about that. Gravity, 10 to the 35th. Cosmological constant, 10 to the 120th. That's something that would be easily memorizable, and you could share with a person, saying, what do you think about this idea that the universe is exquisitely, finely tuned for life? Second, learn just a couple analogies to explain the improbability, to give some teeth to this. So I gave you a few already. I gave you the example of the Powerball being 1 in 300 million, the number of cells in the human body, 37.2 trillion, the number of seconds that the universe has existed, 10 to the 18th power, the width of the universe being 20 billion light years, actually is 10 to the 28 inches. 10 to the 60th power would be shooting a 1-inch mark geometrically, not linearly, geometrically blindfolded at one part of the universe from the planet Earth, supposing you could shoot that far. Shooting a 1-inch mark blindfolded, that would be 10 to the 60th power. So no matter how you look at this, these are incredible, but to give people some teeth to it. So another example would be covering the entire continental North America with dimes, and stacking dimes on the entire continental North American continent to the moon, 239,000 miles. And then doing that on 1 billion other continents, painting one dime red and asking somebody to blindly pick that out of that incredible amount of dimes. What is that? That is 10 to the 37th power. That's the chance. So dimes from the Earth to the moon on the entire North American continent, and do that on 1 billion other continents. That is 10 to the 37th power. If anyone was able to get that red dime, you would call foul. Absolutely you would. Finally, number 3, share stories of atheists who have found this argument, this evidence, very persuasive. I'll give you one example. Antony Flew. Antony Flew was an atheist for over half of a century. He sat under C.S. Lewis in Oxford University. He didn't think that Lewis's arguments were very powerful, persuasive, cogent. He went on to have a career in philosophy, and he debated the best of them, William Lane Craig, Gary Habermas, and more. I mean, debating atheism, teaching atheism. He taught at Oxford, he taught all over the world, wrote tons of books, and then in 2003, he signed the Humanist Manifesto, which is an atheistic tract. But in 2004, his faith in atheism began to weaken. Incidentally, he was friends with Gary Habermas, a friend with whom he had debated over the argument for the resurrection. And him and Habermas kept up a friendship over years where they'd call each other on the phone and they'd write letters to each other. Well, one day, Tony Flew calls up Habermas and he says, "I think I've become a theist." And Habermas says, "You must be hallucinating." I don't know what he said. Something to that effect. Here is the world's leading philosophical atheist. This would be better than Richard Dawkins, by the way. Richard Dawkins is a popularizer. He's a biologist. He's not a philosopher of religion. His philosophy in his books is atrocious. One philosopher, his name escapes me at the moment, but one philosopher who is a atheist, it'll come to me, Thomas Nagel out of the University of Chicago. After the God Delusion came out in 2006, Nagel said, "Please, Richard, shut up. You're making us look bad," right? Richard Dawkins pales in comparison to Tony Flew. Yet, years later, he came out with a book, There Is No God, scratched out, There Is a God. How the world's most notorious atheist changed his mind. And this is what he wrote on page 88. "I now believe that the universe was brought into existence by an infinite intelligence. I believe that this universe's intricate laws manifest what scientists have called the mind of God." So, Antony Flew becoming a believer in God. Now, some people have quibbled over, was he a deist or a theist? Oh, give me a break. First of all, I think a theist, because he believed that the argument that we're going to study next week for abiogenesis, he thought that was extremely persuasive. But if you believe that life had a design, that means that you believe that some kind of how did he put it, an infinite intelligence intervened. That's not deism, that's theism. It's not that God just wound up the clock and let it go. That's God intervening. Anyways, the point is, Antony Flew became a believer in God. He never, to my knowledge, became a believer in Christianity. However, he said in this book here at the end, he said, of all the purported miracles that I've studied, and he's been in this game for a while, right? He died in his 80s. He's been in academia for decades in the academy. Of all the purported miracles on earth, the resurrection of Jesus of Nazareth has the most evidence, both qualitatively and quantitatively. That's Anthony Flew. He gave the final chapter of his book to N.T. Wright to write an argument for the resurrection. Francis Collins, speaking to Richard Dawkins about faith and religion and science and everything else, and there's a certain point where Francis Collins turns to Richard Dawkins and he says, what do you think about the fine-tuning of the universe? Here's his response.
But you said that, well, it's happened just because of the laws of physics. I want to take this back to that step. Where did those come from?
Well, let's get to that then, because you keep getting to that, and that, I believe that's a very profound. I mean, if somebody was going to convince me of the need for a God, it would be there. It would be not in my own field of biology. And I found, I mean, I've read The Language of God, and indeed I reread it today. When you come on later to the origin of the physical constants, now that's getting warm. That's getting close to a good argument. Unlike the morality one. You might convince somebody like me to be a deist, but then you suddenly say, okay, well, because of...
he's converted. Did you hear that? Right here.
because of the fine-tuning argument. But then suddenly, okay, then we get Jesus Christ, and then we get crucifixion, then we get resurrection, we get virgin birth. That's nothing to do with it.
He says if there was a good argument, he's not willing to concede this is a good argument. In fact, we're going to see what his rebuttal to this is later on in our course. But if there was a good argument, this would be it, the fine-tuning of the universe. Now, to be clear, Richard Dawkins is not becoming a believer in God. He even says, I want to qualify that. I'm not saying that. I'm saying this is good evidence. You know who else believed it was good evidence? Christopher Hitchens, one of the other four horsemen of the new atheism. Chris Millikan, who is a professional philosopher and atheist. Michael Shermer, in his book, one of his books on the subject of atheism and Christianity, this, fine-tuning, it comes up across the board. You can't escape this argument. You have to come up with some kind of an explanation. What's interesting to me is Stephen Meyer was debating Michael Shermer on the subject, does God exist? And they shared a car after the debate, and he said, what do you do with the fine-tuning, Shermer? And Shermer says, well, you know, there's all these different explanations. There's the multiverse and weak anthropic principle and yada, yada, yada. And Michael Shermer concluded, and finally Stephen Meyer says, but do you believe that? And Shermer smiled and said, no. Those are just his best arguments he can hurl back against it. That's all he's got. This is very persuasive. And to scoff at this and to say, oh yeah, this has been answered. I love hopping on YouTube and saying, oh, the fine-tuning argument answered in 3.5 minutes. The greatest minds on planet Earth right now are dealing with this, and it's all been debunked so easily. No, it has not. In fact, the more we study this, the more we realize the great lacuna in our thinking, the divide, dividing what we know and how we can explain it. This is not a God of the gaps, where the gap is something we can't explain, but over time it becomes clearer. This is a gap where the naturalistic explanation is completely widening over time. The more we experiment, the less we can explain. That's what we're dealing with, the fine-tuning of the universe. Then, I guess this is finally, ask key questions to generate quality dialogue. Something to the effect of, if this is the case, if it really is 10 to the 35th power for the gravitational constant, if it really is 10 to the 120th for the cosmological constant, what would that imply? What kind of a being would you need? Maybe you're seeing some conflation with last week's teaching. What kind of a being would we need to create the space-time matter-energy universe finely tuned? What kind of a being would that be? Well, it must be a being that's outside of space and time, a being that's, as Flew said, infinitely intelligent, and a being that had us in mind, a being that could see us coming, as one scientist put it. So raising questions that can have and really open up and encourage a dialogue, that's a great way to go.